today's video, we are going to have a practice problem about continuity, and we are going to explain everything in details. On the first set of example, we are going to determine whether the following function is continuous on a given interval. On example number 1, we have f of x equals x squared plus x minus 2 at negative infinity to positive infinity. So to check whether the given function is continuous in the given interval, let us set values for x. And let's say we have negative 3, negative 2, negative 1, 0, 1, and 2. So let us create a table of value. So we have the values of x from negative 3 to positive 2. And we are going to substitute these values of x in the given function to find the values of y. So let's start with x equals negative 3. So since our function is x squared plus x minus 2, we are going to substitute all the values of x to find the values of y. So we have y equals negative 3 squared plus negative 3 minus 2. Negative 3 squared, that is 9. Negative 3 minus 2 is negative 5. And 9 minus 5 is 4. And then let us have x equals negative 2. So this will give us y equals negative 2 squared plus negative 2 minus 2. Negative 2 squared, that is 4. Negative 2 minus 2 is negative 4. And 4 minus 4, that is 0. And then let us have x equals negative 1. So we have y equals negative 1 squared plus negative 1 minus 2. Negative 1 squared is positive 1. Negative 1 minus 2 is negative 3. And 1 minus 3 is negative 2. And then we have x equals 0. So we have y equals 0 squared plus 0 minus 2. Let us cancel this one. And that will give us negative 2. And then x equals to 1. So y equals 1 squared plus 1 minus 2. 1 squared, that is 1. 1 minus 2, that is negative 1. And 1 minus 1, that is 0. And lastly, x equals to 2. So we have y equals 2 squared plus 2 minus 2. Let us cancel this one. 2 squared, that is 4. So as you can see, if we are going to extend the values of x from negative infinity up to positive infinity, the given function is continuous at every real number. So that means to say the function f of x equals x squared plus x minus 2 is continuous at negative infinity to positive infinity. On example number 2, let us determine whether the given function f of x equals square root of 9 minus x squared is continuous in the given closed interval negative 3 to positive 3. Since the function f of x is only defined if 9 minus x squared greater than equal to 0, and since 9 minus x squared is a polynomial function, then it is continuous everywhere. Therefore, whatever 9 minus x squared greater than 0, the function is continuous in the open interval negative 3 to positive 3. So let us check whether the closed interval negative 3 to positive 3 is continuous in the given function square root of 9 minus x squared. So let us have the first one. So let us have f of a exists. So let us have f of 3 equals square root of 9 minus x squared. This will give us 9 minus 3 squared, and that is 9 minus 9, that is 0. And then let us have limit of f of x as x approaches 3 to the left, and that is limit of square root of 9 minus x squared, x approaches 3 to the left. So this will give us 9 minus 3 squared, and that is 9 minus 9, that 9, that is 0. So as you can see, the limit of f of x as x approaches 3 to the left is equal to f of a. So that means to say it is continuous from the left at 3. And then on the second one, let us have f of b exists. So let us have f of negative 3. So this is 9 minus negative 3 squared. This will give us 9 minus 9, and that is 0. And then let us have limit of f of x, x approaches 3 to the right, and that is limit of square root of, for negative 3 to the right rather. So this is 9 minus x squared, x approaches negative 3 to the right. So let us have square root of 9 minus negative 3 squared, and that is 9 minus 9, that is 0. Now, let us have limit of f of x, x approaches negative 3 to the right, is equal to f of a, which is negative 3. So it is continuous from the right at negative 3. So therefore, the function is continuous on the interval negative 3 to 3. So this will be our answer. In example number 3, f of x equals 5x plus 3 if x less than 1, x squared plus 4 if x is greater than equal to 1 but less than 2, and x cubed if x is greater than or equal to 2. So let us check whether the given values of x are continuous in the given function. So let's start with x equals to 1. Since the value of x is 1, we are going to use the function 5x plus 3 and x squared plus 4. So we have 5x plus 3 and x squared plus 4. So let us substitute the value of x in the given function and let us check if we have the same value. So 5 times 1 plus 3, that is 5 plus 3, that is 8. And then on the other side, we have 1 squared plus 4, that is 1 plus 4, and that is 5. Since the first function, if x is less than 1, is 8, and the other function equals to 5 when x is greater than equal to 1 are not equal, so therefore, it is discontinuous at x equals to 1. How about if x equals to 2? So we have here x squared plus 4 and then x cubed. So we have 2 squared plus 4, that is 4 plus 4, and that is 8. And the other side, we have 2 cubed, and that is 8. Since the value of the function are equal, which is 8, therefore, we can say that it is continuous at x equals to 2 and discontinuous at x equals to 1.